Welcome now for real to OWASP Switzerland's session today. My name's Sven. I'm one of the co-leaders of OWASP Switzerland, and with me co-leading the local chapter here in Switzerland is Patrick and Rob. So if you want to support OWASP, please feel free to become an actual OWASP member. You can do that as an individual or as a company, and it will make sure that OWASP has all the funds to support all the great projects that are available to anyone on the planet for free. If you have any questions during the presentation, you can either directly ask them inside of the chat room that we have on YouTube, or what you also can do, you can go to owasp-switzerland.ch, and there you can also pose your questions. The benefit of that platform is that you can do it in an anonymous way, because on YouTube you actually need to have an account to put in your questions. If you put in any questions, be assured that we will try our best to answer all of them at the end of the actual presentation. And now, without further ado, we come to that presentation, which is done today by Patrick. So thanks very much for being with us and giving the presentation. And this will be about token-based authentication architectures, so a very modern topic that a lot of companies currently struggle with, and I'm really eager to hear more about it. So thanks, Patrick, for being here, and the stage is yours.
Hoi zusammen. Well, good to have you still here then, and thanks very much again for the kind introduction, Sven. So for the next 50 to 60 minutes, we'll dive now together into token-based authentication. My name is Patrick Steger, and I pay my bills thanks to being principal consultant for security at my company, Zühlke Engineering. This means I do consulting and implementation of security solutions for selected customers. Besides that, I have a few security-related hobbies. For one, I have the honor of being a co-lead for OWASP Switzerland, together with famous Sven and Rob. I'm also contributing to and co-leading the OWASP Application Gateway project. But we're here today for this. We start with the typical situation we might find in our daily work life. Then we're going to discuss when a token-based authentication architecture might be a good idea. And we'll investigate a few architectural options we have. During this last stage, we will also introduce relevant components for such an architecture. We will, however, leave out most of the requirements discussion today, but sometimes they shine through a little bit. As you can see, we have a lot of cool stuff on our table. And if you have any ideas for extensions, you see other architectural options or alternatives, please share them in the chat and we can take that up and discuss it afterwards and share it with everyone. Also, if you have questions, please add them whenever you want. As mentioned, I'll answer them typically at the end of the talk, just to keep the flow going. So let's start at the very beginning, what we usually have. And this is here on the left side. We typically have a bunch of players today. So first of all, there may be web applications, be it single page applications or classical web applications. We might also have mobile applications, or we might have API clients that actually play the client parts. They are usually internet-based. Besides that, we'll typically have front-end services or internet-facing services, or however you will call them, they are responsible to provide an interface to the clients. Then we'll have a bunch of backend services in this area. They provide typically business logic and implement business logic, execute that. They can be REST services, they can be EJBs or whatever. Then we'll have some tasks or batches or schedulers triggering events and starting often backend service functionality. Some of the calls between services or wherever might even go through queues or other asynchronous mechanisms. Even databases may be involved. All of the later guys here, they are usually hosted in our cloud or by our cloud provider or even on premise. Now, calls can be executed in the security context of either end users, which is the red arrows, or it can be executed in the security context of service users, which are the blue arrows. With security context, I mean that in the red case, authorization is based on the rights of the end user. Or if it's a security context of the service user, this means the call is executed with the rights of the service user. And yes, you're absolutely right. Between two services, there can be calls of both types. So it could be calls executed in the security context of the end user or of the service user. Perfectly normal, but it would clutter the diagram, so I left it out. Now, what's the issue, or what do we face with this typical situation? First of all, we have many different types of credentials. There are passwords, maybe certificates lying around. We may even have to be aware of two-factor authentication and so on. And basically, we do not want to handle all this on our own. We do, in addition, not know how we can securely transport the original user's identity to backend services. There's no real standard for that. But often authorization actually depends on the end user's rights, which is obviously a good thing. So we do not know how to impersonate the user in a standard way. And impersonation means the calling service acts as if it were the user directly, which means that the receiving service is not aware that the call was in fact from someone in between. And we also have no way or no standard way to implement secure delegation, where delegation or proxy means that the receiving service is actually aware that it was called by the calling service on behalf of a user. On top of all this, all our services often require quite tight integration with external services, such as the Active Directory, public key infrastructure, and so on. So if something changes in the outside world, then often all our services need to be changed and redeployed too. What we instead want to target for is that we want to become independent of external services and systems. We want to be based on standards as much as possible so that it's easier to switch frameworks or products. And we want to have only as much complexity as required for the security requirements of our service we implement. So basically, complexity should scale with security needs. Now, how can this conceptually work? As I said, primary, we want to become independent of others' credentials and security mechanisms. Others depends a bit on your context. It can be outside my project, outside my company, or even outside my ecosystem, or something in between. So it really depends on the solution you're working on. What we want on the other side is we want to control what credentials and what security mechanisms our services must understand. And with us, I obviously mean our project, our application, our service, or even our whole company, depending on the solution you're working on. So changes should have as few impact on us as possible, and we want to control security mechanisms to use a general purpose credential if possible. And a token could actually be that general purpose internal credential that allows us to authenticate and identify end users as well as services or systems users in a standardized way. The best known player for such a token is the JSON Web Token today. Note, please, that throughout the talk, I will most likely use token and JSON Web Token interchangeably. And to make things even more interesting for you, I will most likely also call a JSON Web Token JWT, JOT token, even JWT, or something like that. So they all mean the same, don't get confused. And because we will build our authentication architecture around such tokens, we'll call this token-based authentication architecture. Now we will look at architecture options we have. Some of them I've implemented at some customers. For others, I've defined blueprints or strategies for customers, and other options are just conceptual ideas how to progress further. And this is the reminder actually of the talk, investigating all these options we have and all these architecture types. Let's first discuss with a very simple, very naive initial architecture. But it helps us to introduce maybe the three most important and most relevant components in such an architecture. We will discuss these three components first and then come back to this slide and see how it works. First, we will discuss an identity provider, or in short, IDP. Then we'll discuss a protocol to authenticate end users and services. And we'll discuss a means to transport our tokens on the server side. So, identity provider, authentication protocol, and transport. The identity provider, or IDP, respectively often also called the authentication server, is responsible to authenticate users and maybe also services and issue a token, usually a JSON Web Token, in exchange for successful authentication. So basically, a user can enter his username password and receive in return a JSON Web Token that will then be presented to the front-end service. Also, a service could use its service credential and in exchange receive a JSON Web Token that's issued for the backend service or the front-end service. Now, such JSON Web Tokens are very well standardized. There are multiple RFCs flying around defining how they have to look like. And an IDP may obviously also provide additional services. For example, a service to validate issued JSON Web Tokens, or a service to query for information and so on, but they are not very critical for our architecture right now. Now, the next component defines how an end user's client, so browser or mobile app, interacts with the identity provider and the front-end service in order to prove its identity to the service. So this is basically what we call an authentication protocol. In today's solutions, this should usually be OpenID Connect or maybe OAuth 2. But in special environments, it might be something completely different. For example, I had one customer where this was actually Kerberos because it was intranet. However, in the end, we conceptually get a token or an otherwise provable piece of identity information in our front-end service. Also, our services may get such tokens for themselves using an authentication protocol. For example, they may use the OpenID Connect client credential flow to get such a token. The last component we introduced was the server-side transport protocol. So we need a means to securely transport our token between our services. And the best way to do this today is according to the so-called bearer token specification, which again is an RFC specifying a very simple HTTP header defining how a JSON Web Token can be transmitted over HTTP basically. And by the way, we usually have to use HTTPS together with the bearer token specification because our tokens are credentials actually and need protection. Please also note that for protocols outside of HTTP, we are very fast on our own and things soon get vendor specific or custom built. So if you have, for example, an EJB running at the endpoint as a backend service, then if you have a Wildfly application server, there it would be the Red Hat way of how you transport this token to the EJB. Now, using a JSON Web Token has the advantage that token validation on the receiver side is straightforward. There are again lots of RFCs defining how this must be done. And most of our frameworks or technologies we use already offer this out of the box. When it comes, however, to how a validated JSON Web Token is stored for the request and is used in calls to other services, there you often are on your own and you need to design this into your architecture. So now that we've introduced these three components, let's head back to the architecture description. So we understand now how this basically works. The client, thanks to the OpenID Connect protocol, presents a JSON Web Token to the front-end service. The front-end service verifies the JSON Web Token, and if it's happy with it, executes. It may also impersonate now actually the end user by just adding this JSON Web Token to downstream calls, for example, to backend service 2. Backend service 2 again validates the JSON Web Token and performs its activity. And it may forward the token again, and so on. You get the point. If we have now a service such as the front-end service that needs to execute a call in its own security context, then it calls the identity provider using the OpenID Connect client authentication flow and gets in return a JSON Web Token issued for the service user, which can be added to the downstream call to the backend service 1. So what are now the qualities of this very simple architecture? First of all, we still heavily depend on the identity provider here, which I showed that it's internet-based. Obviously, it could also be a company-based identity provider or even your own application's identity provider, but we don't care too much about that. However, we depend heavily on this identity provider when it comes to the token structure, the validity of the token, the content of that token, and so on. Worse, if a token issued by this identity provider is lost somewhere in the internet, it may be used by an attacker to directly access our services, our backend services, without restricting the attacker to the public interface, which is a bad thing, obviously. On top of that, also all our internal services require an account with the identity provider just to be able to get a JSON Web Token for themselves. And even if we have a token renewal or we need token extension, that will be very hard to handle. We'll have to handle access token, refresh token, IDs token, and so on. And this may be even on backend services, which will be a hassle. So overall, for very small applications like a single service or a traditional free-tier application, and when the identity provider is actually a company identity provider, this kind of architecture might work. It's, however, nothing I recommend in general to do. Make really sure you understand the implications here if you go that way. So now let's improve the situation. What do we do? So first, we'll again discuss this new component we'll introduce, and this is the application gateway. And afterwards, we come back and look how the architecture has improved. So the application gateway is something that almost all architectures will profit from. It is able to translate external credentials into internal credentials. The main reason for this is, one, we want to decouple, make all our services independent from the outside environment and let only the application gateway handle everything in the area of translation and outside credentials. And two, obviously, if we lose a credential on the outside, it cannot be used on the inside. We are limited to using the public interface opened by the application gateway, which is a good thing. So to make this happen, the application gateway actually needs to validate outside credentials and issue internal credentials. And in our case, this means the component must be able to use internally used JSON Web Tokens. So what now is this application gateway? Well, an application gateway can basically be anything. It's just a name we put here. It could be a product such as an identity provider. For example, it could be a Keycloak or Okta or whatever. Remember, they are quite heavyweight and they are not so easy to extend, and most likely you will need to extend them. The maybe cleverest solution would be to use a reverse proxy type, something like the Spring Cloud Gateway or an OWASP application gateway that's built on top of the Spring Cloud Gateway. Or obviously, you could also build something from scratch if you want to. I personally made good experiences with the OWASP application gateway and with the Spring Cloud Gateway. Both of them work fine. As we will also later see, the application gateway is also a natural choice to take over additional responsibilities, such as it will be a base for the trust zones, we'll introduce them, for token exchange functions, for session handling, and so on. Be also aware that you may use multiple application gateways in your architecture that can issue inside tokens for the same or for different applications. So it's completely okay, for example, to have conceptually one application gateway for the whole company, for just one application, for an organization unit within your company, for just a simple service or something in between, whatever works best for your case at hand. Oh no, the commercial port. So howdy, folks, how are you? On your way to build a great token-based architecture, are you? Well, look no further. There it is, the OAG, the OWASP Application Gateway. It's here to enable you to build great token-based architectures faster. Get your copy of the OAG today. The OAG is an HTTP reverse proxy that sits between your web application and the client. It handles OpenID Connect login, session management, as well as other security aspects and even operational requirements such as correlation logging or tracing, for example. And it issues JSON Web Tokens to downstream systems. All for you, done. So for you as a developer, OWASP Application Gateway removes the hassle to implement this complicated OpenID Connect logic in the backend, and if you want, even in the front end too. So you can totally focus on your application logic. And we have the cutest mascot ever. But wait, man, you're kind of kidding right now. We have still to build a lot on our own, right? Oh, well, yeah, all these advanced features, like token exchange and stuff like that. Yeah, they're not yet in there. Well, these silly developers are just so lazy. I've told them they should do better, but it kind of doesn't work like that. And it's kind of bullshit. Oh, wow. So I'm glad to be back to business here. The last thing we actually discussed before the interruption was the role of an application gateway. Now let's go back to the architecture slide and see how this looks like. So in this architecture, a client again goes through the application gateway now to access the front-end service. Everything remains as seen, so OpenID Connect with the identity provider, token is verified by the application gateway here, and the application gateway issues an internal JSON Web Token that's issued for the front-end service and passed down to the front-end service. The front-end service receives the token and validates it. Now the front-end service can pass down this internal token using, as before, the bearer token specification and impersonating the end user. If the service now needs to make a call in its own name, so in its own security context, it may ask the application gateway to give them an inside JSON web token issued for the service. And obviously the application gateway will authenticate the front-end service for that. So with this simple addition, we gained quite a lot. First of all, we became independent from outside credentials and outside authentication protocols and flows. The only component that needs to adapt is the application gateway. So internal services no longer depend on the outside token, but only on the inside token we have complete control over, which means we can issue tokens that fit their needs regarding expiry, content, and so on. The second big thing we gained is that a successful attacker stealing a credential on the outside cannot any longer directly access a backend service with this credential because it's not accepted. He is restricted to going through the public provided API, which is a very good thing. And only these two things now means that we have drastically reduced the risks of our architecture. The cost obviously is that we have to maintain and operate an additional component, our application gateway. This kind of architecture actually can work for many applications. In fact, it's basically what I saw implemented for a major company's top business line applications. It's most likely not a fit for a whole company. So scope here is usually a project, a department, or an application or something like that. But this is also the first step I saw a financial institution taking. However, their strategy is to go further and to enable token-based architectures on a company scale. And let's see what they decided to do as a next step. So the next step is to enforce trust zones or define borders. And what I mean with a trust zone is this. We define a set of services where all services accept a token that's specified to be valid for this community of service. In the JWT world, this often means that its services accept the same audience set in the token. Technically, they call this the auth claim. And as a side note, maybe a claim is nothing else than a verifiable assertion made by the token issuer about the identity mentioned in the token. So audience basically means that JWT is meant for a community identifying themselves as X. For example, the upper half here of our services consider themselves as community of trust zone 1 or TC1. So they have a JSON web token containing a claim with audience TC1. The lower services here, the green ones, they consider themselves community of trust zone 2 or TC2. And this is how this architecture now works. User again calls the front-end service through the application gateway. Application gateway verifies the token and issues an internal token, In this case, JSON Web Token with audience TC2. Frontend service 2 validates this token and impersonates the user, passes the token down to backend service 3. Backend service 3 now again validates the token, and now things start to get different. Backend service 3 now wants to call service 2, but he can't directly pass over the received JSON Web Token because it has a claim of audience TC2, and backend service 2 is just accepting tokens for audience TC1. So what the backend service 3 does is it approaches a so-called token exchange. And it just requests from the token exchange a token issued for audience TC1 in exchange for its own JSON Web Token plus its authentication. So having made that, backend service 3 has a token he can add to the call to backend service 2. Backend service 2 validates the token, has the right claim in it, is valid, and can pass that down to the next services if it wants to. Please note that the token exchange here can and actually should restrict what services can change tokens to other trust zones. We could also even further improve this architecture by placing an additional application gateway in between backend service 3 and backend service 2, so that backend service 3 never gets in possession of a JSON Web Token of trust zone 1. And the application gateway handles this very similar how our initial application gateway handled the outside world token. So with this, we added an additional compartment, making it even harder for an attacker to spread across other applications and access their data. So this is another risk mitigator, I'd say. Now let's see what we could do in addition. One of the maybe most important security controls we could add is short token validity. So make sure that the internal web token is valid for as few minutes or seconds as possible. This might actually be your best weapon to argue even more security controls away. Because if you have short token validity, other securities cost to value ratio usually gets very bad because they mitigate just a bit of risk for quite high cost and complexity. Now what we need to enable short-living tokens is we need a way to actually refresh tokens or even revive them again for a given time span. And for this, we can again leverage the token exchange. It can provide such a token exchange within an extra endpoint, and it can work like this. So backend service, if backend service 2 receives a token that's valid just short time, like here, then it may approach the enhanced token exchange, may request a refreshed token in exchange for authentication and the original token we pass in, and get in return a JSON Web Token with an expiry more in the future. It is also possible to enable token revival. This might be an option, for example, when you kind of load an offline workflow from a database or from a batch script and you actually need the end user identity security context to be re-established. So there it can be that the original token is already expired, but we can assign the workflow step or the workflow service the right to revive the token, similar to refreshing it using this enterprise token exchange. Please also note that OpenID Connect knows a thing called refresh token. This can work well in very simple scenarios that are very end user centric, like our very first architecture, but it will in most cases become a pain and even not feasible in more complex solutions, so consider well. However, with this feature of short-living tokens, which means a maximum of minutes, will be fine in most of the cases, I guess. However, let's quickly review what security qualities we still don't provide yet. So these are our main gaps. First of all, we actually have no service authentication. This means the direct caller is not authenticated in most cases because we authenticated simply based on the JSON Web Token of the end user. So you can kind of think of this conceptually like a session ID known by all services. The second thing is we have an invisible call path. So as said, until now, we always impersonated the end user. So the receiving service was not aware what service was actually acting on behalf of the end user. The receiving service, therefore, has no way to validate if the request came from an expected direct source or not. Then we have another type of gaps still there. We have no way today to revoke tokens. So if a token is lost or stolen, or if we want to simply perform a logout, there's no way to mark a JSON Web Token as not valid anymore. And we also have no way to find out if a token was actually used the first time or whether it was reused. People call this a reply attack. So we have no way to counter reply attacks today. Now, what can we do about that? If we want to make delegation visible and also authenticate the calling service in one go, we could do this again with an extension in the token exchange. So here we can provide an additional service endpoint to exchange the received JSON Web Token into a JSON Web Token that contains delegation information. So basically we add something like the ACT claim, which stands for acting. So delegation information can be the ACT claim in a JSON Web Token. This ACT claim can be even stacked so that it allows to track the whole path the JWT took through the system and through the applications. There even exists an OAuth 2 protocol extension called On Behalf of Flow that specifies how this might be done and should be done. And because we need service authentication when exchanging the token and making sure we get one with the ACT claim with our service in, this also arguably resolves the missing service authentication risk, because the receiving service can actually verify that the ACT identity is allowed to access it. This is due to proper authentication that was performed by the token exchange or application gateway before issuing the new JSON Web Token with the ACT claim containing the service user. Please also note that we're not restricted to a certain level here. We have many options actually. We can make delegation visible only when crossing a trust border, for example, here between services 3 and 2. Or alternatively, we could do it for every call between services. Or we could require it just for very special services with high sensitivity. So it's all basically up to the requirements. And as we've seen, putting verifiable delegation information into the token is one way to go for actually authentication and visible delegation. But there might be alternatives, right? Let's quickly think what an alternative could be. Two alternatives pop up immediately, I think. First of all, we could provide explicit service authentication to the called service. So two services could, for example, use IPsec or TLS mutual authentication, meaning client certificates, to authenticate each other. Or we could use API keys to authenticate the service. Plus, on top, we still have to pass the original end-user JWT along because we still need this information. Note that this is not standardized, but might work. Another alternative we might try out could be a compensating control or workaround with the help of a host-based firewall, for example. This would then mean that we only allow IPs known to be good callers for every service. Yes, this is strictly speaking absolutely no service authentication, and we lose completely visibility of delegation, but it might be a good enough option for some cases. Again, as with the first solution, it would be possible here to fine control complexity by only enforcing authentication when going over trust zones, for examples, or for very sensitive services. So now for the last two things we're missing. First of all, revocation. Revoking a token actually means we mark it as invalid so that it won't be accepted anymore by any service. To revoke an issued token, we can either notify all services, and all services keep book of what JSON Web Tokens actually were revoked, or we could offer a mandatory central validation services that does all of this. To detect reply attacks, that means to find out that somebody tried to reuse or send a token for a second time, we could also use the central verification service that keeps book about all tokens it has ever seen. Or we again need to make sure we have one service equaling one trust zone and each service keeping book of all the tokens it has ever seen. This would mean that each token is only valid for exactly one service, obviously. Anyway, all of the solutions we discussed right now require at least one new JSON Web Token per call, which by the end would be the security requirement in this case anyway, I guess. and or it requires central verification. And this means considerable overhead and performance penalty. So it's worth remembering that some of the limitations we actually had before discussing this slide can also be treated as enablers for features. So, for example, if the reply detection is not implemented, this allows us to reuse tokens, save call round trips, and greatly improve performance and reduce complexity. So in many cases, the risks of this slide at least will be acceptable. In many cases, it's not reasonable to implement countermeasures, especially when we have short-living tokens, because then they expire anyway quite soon. But as always, in the end, to mitigate or not to mitigate needs to be assessed with the customer and documented for every application we actually build. So with this, I'd like to conclude today's introduction into token-based architectures. If I could wish for one thing you take with you, it was this. OpenID Connect is for end-user authentication in an application. What comes afterwards needs consideration, and I call it token-based architecture. So finally, we can start the Q&A session, I guess. Well, Sven, what ideas do we have in the chat? Or who may we answer a question, actually?
Yeah, thank you very much. So let's quickly dive in. We do not yet have too many questions, but so I guess one of the reasons most likely is that people actually paid good attention to your presentation. So
Sven, are you still on mute?
Oh, yeah, that would definitely help. So I guess now everyone can hear me. So perfect. Maybe if we can stop the sharing of the slides, then I can also make sure that everyone can see us. Perfect. Okay, yeah, so thanks very much for the presentation. We have questions there, not too many for now, but I guess people really paid attention to the presentation and were not just typing away. But for everyone that attended the session, please feel free to still put in any kind of questions that you might have considering any parts of the presentation. So one question that came in, and I think you answered that already, but I'm still going to ask it because maybe you have some more insights on that. And that was regarding when we talk about the external credentials that we have, and compared to or in combination with what you also mentioned, the standardized way of the on behalf flow in OAuth and OpenID Connect. So can you maybe elaborate a little bit more on how this might play in regarding the transformation regarding external internal part of the whole thing, or if this is only something that actually is something that can be implemented regarding the internal credentials to evolve through more than one service?
Well, it depends. It's for sure a good idea to add it on the internal part if you have a more complex architecture out there and use this on behalf of flow. So you make actually the path through your system visible and delegation visible. As it is a kind of standardized extension, there are also a kind of identity providers out there that already support this flow out of the box. So it might be that you have a company identity provider that supports this flow, and then you could also use obviously your company's identity provider to kind of use the on behalf of tokens. So that would be for sure an option. We're then usually back to the very simple architecture when directly using something we're depending on externally. It might be an option.
Okay. Cool. So one other question we have here is if you would have to choose. So I mean, overall the presentation was heavily regarding architecture. So normally we want to reduce complexity, and this is also something you mentioned. Would you, from your point of view, if you really would have to decide one or the other, would you say that the application gateway is more of a benefit regarding security or reducing complexity in the overall architecture?
Well, we had at least at one customer, it was a huge simplification for us because we could really get rid of all these dependencies of Active Directory and how they think things should be, and delegation, how they thought would be right. And we just with switching to this internal JSON Web Token, we had now finally had all control we needed to really work independent, and we were now able to also evolve with that company. So they plan to introduce an OpenID Connect server in the near future. And for us, this is quite easy because we just switch the gateway to using the OpenID Connect IDP instead of the Active Directory directly. So it really can be a huge benefit, in my opinion. And it's worth the effort as soon as you have a couple of services or applications behind there. If you have just one application or one service, you're probably better off with the very simple approach.
Okay, and how do you see from your experience now working with different clients? Is it more something that companies should do earlier on, or are companies opting for an application gateway too early? So I mean, either they are already having a lot of complexity and then they basically rebuild stuff, or do they start too early actually having something that doesn't really bring them a benefit? So what do you see more often?
Mm-hmm. Well, maybe it's one thing is that application gateway can actually be used in very different ways. And what I quite often see, people call it application gateway. There are products that are called that way, and they are basically used to kind of unify all internal services into one gateway out to the outside world. But that's not actually what we're talking about with a token-based authentication architecture here. We're talking here basically about an application gateway that is actually here for our application to provide value to our application. So these kind of global heavyweight products we often see, I tend to believe that they're sometimes used too early and make situation more complex, versus this kind of lightweight application gateway that's just here to simplify matters for your application is something I believe you can't start actually too early. Except if you have, I wouldn't start with one if you have just one service.
Okay, yeah.
Because it's provides no value there.
Definitely, yeah. Okay, so let's see. More questions are coming in. So one question we have there, or there are more and more and more. So we should answer them faster if they are coming in that pace. So One question is, let me quickly check, is on the end user side, and then between the services, which quickly check if I understand the question. I'm just going to read it to you. I think you might get what the actual question is. So, in an architecture where cookies are used to handle an access JOT token, and I don't get the question. That's a combination. I guess the comments need to be shorted to actually fit in the chat. So, okay, now this is a four-part question. Okay, now I understand. Sorry for that. So, the question is in an architecture where cookies are used to handle an access JOT, and where they would be safely set as HTTP only. Your client would then have to have no way of log out while being offline, as it needs the server to clean the cookies. Meaning an offline user might think he logged out, but the cookies would still be set. And the question here is, how would you rate such a vulnerability, and should a mitigation procedure be in place, like cleaning the cookies client side by just overwriting that, for example? And would you even consider that like problem of still having the data there as an actual vulnerability, or is that just like acceptable?
Well, depends. In my opinion, actually, it is a vulnerability, obviously, because, well, even if you kind of kill the cookie from the browser's cache, if it's somewhere out there, it could still be used, right? So it is a vulnerability, definitively. Now it's to assess whether it's worth to do something against it or not. Now, if you have very short token lifetime, one might say that's acceptable for me and done. Or you may say, well, but again, I mean, we have this situation because most of the especially single page application frameworks kind of provide this cookie based, they kind of abuse cookies or JSON web tokens for session handling. That's just a fact. And that's why we have that. The solution obviously would be that the application gateway actually exchanges the JSON web token with a real session cookie. So a session ID, it actually also handles and tracks and then requires relogin with a JSON web token if the cookie actually is no longer valid. But that requires extra work. As a side note, the OAG actually offers this option to kind of do session handling for their users. But it breaks most of the frameworks out there. That's just a fact. And that's why we usually see that this risk is taken.
Okay,
or
but
do you have other experience when, I mean, lots of
I
tests and see this always, I guess.
Yeah, I mean, basically what you're saying. So in a lot of cases, it's somewhat accepted, or at least like it's reduced in a way that you're saying, hey, if we still have data in a system that could be abused, but if somebody actually gains control over that system, we have way bigger problems than a single user session. So then this is not increasing the impact it would have. So basically cleaning it on the client side would be enough, because yeah, if you have like a system like, for example, the application gateway under your control, then it's most of the time it's not about the single session. If you can basically just get whatever comes in and out there, then your issue is not that somebody can still use a session that he stole, for example, from a local cache or something like that. But still, yeah, totally understand also the point and see that it is a security issue. It's just a question: is it worth the effort to like properly solve it? And yeah, so thanks for that. So let's see what else we have. Yeah, there. Not sure if this is just a comment to the other ones, the question is regarding, yeah, the issue would be on the refresh token, as the access tokens are actually short-lived. So and then, yeah, there is multiple people thanking you for the presentation, so that's also very welcome. So means that people actually enjoyed it. Very good.
Thank you very
Including
much.
myself, of course. And yeah, what else do we have? We have one question. This is regarding what kind of, so you showed multiple like extensions on how far the architecture could go in terms of like, be it, call it security or capabilities that it provides, and from like really simple use cases to ones that are much harder to actually implement, because they're more widespread also over maybe even a whole company. So which architecture approach would you recommend if you have an architecture that is solely based on service user authentication? So I guess the question mainly is if there is no kind of end users involved. So I would say that means it's basically only the internal part that you showed, which normally would even be behind the application gateway. So what kind of architecture would you recommend in that use cases?
Good question. Well, obviously you could do a token-based approach anyway with JSON Web Tokens issued for the service user, but is it worth it? That's the question. Maybe you're better off with if you have good infrastructure out there, if for ready to deploy for like Ansible or whatever, then maybe a TLS mutual auth based solution could be an option for you. I don't like the approach where you have directly exchange user password between services or API keys between services. I really don't like this approach, which then brings us immediately back to a token-based solution again. I think you'll have kind of these two options in the end.
Okay. So
then you have a better idea, or
sorry?
you have a better idea or another idea?
Not really. I think the main question is really what is the like also threat scenario that you have, because as you said, so of course you can put in as many application gateways and put out as many like delegations and things as you wish. So the question there, I think, is more, is it actually needed? Because I mean, in the end, a service, depending on how you use a service and how far it goes, you can basically use it interchangeably with an end user. It's just like some application instead of a user that actually does something. So I mean, depending on who you trust at what point, it's not really a big difference if it's actually a service or a user. And so I think it mainly comes or boils down to what kind of trust architecture you have over like the whole architecture of your systems.
Right.
There may be also an additional question that I have myself, because what I've already seen, at least with one bigger client, that went to go more and more into like the whole Kubernetes namespace or space. So what they're basically doing, they try to have their microservices integrated in a way where they say they have sidecars attached to them, so sidecar containers for all of them, and they have I wouldn't say they have the exact same feature set as the application gateway as you showed it, but at least parts of the feature set that is provided there, they're directly attaching to each and every application and have basically a distributed way of implementing that. What do you think about this kind of approach instead of having it like really a gateway or in terms of an entry point to a whole network of services and systems?
Mm-hmm. I think for a system like a Kubernetes cluster, this actually can work. It requires you to have Kubernetes really under control in the end. Because, well, a sidecar just remains basically an independent thing, more or less, if you do it wrong. So you have to make sure they're really that close coupled, and the sidecar really protects the real service. But it's an acceptable solution, in my opinion, to use that.
Okay.
I very, very personally, I prefer if the service is in control. But that's more like, I guess, a personal preference, because for me, layer 7 control is the ultimate control. It's hard, you can't go in between there. So, that's more like personal.
Yeah, so that's of course also I think heavily depends on the overall infrastructure, because as you mentioned, for example, before, as long as you have like internal traffic that you fully control there on like a Kubernetes cluster, there might even be solutions that already provide a lot of what you actually want to have regarding authentication, authorization, that might be enough if you have the mutual TLS approach that gives you like every decent service mesh implementation that already implements something like that. Of course, there is then the question how it's granular of how granular the authentication needs to be. If it's just like, can service A talk to service B, then this is very easy. If it gets more complicated and you actually need something like we need to do it with a specific service user, we need to have even impersonation, things like that, there I guess it makes actually sense to have an extension to what the average service mesh provides, even if it's then like as a sidecar on the different services, or if it's like a central point where you actually do the transformation.
Yeah, good point.
So yeah, I think there are currently no more questions. So last chance, if they're popping up in the next few seconds, then I'm more than happy to ask it to Patrick. So let me quickly check that we didn't. Yeah, there's just a comment regarding the beer and bearer token. So depending on how you actually say it, so depending what you like more, the bears or the beers. So
I like the beer.
Yeah, so I think it's maybe independent if it's correct from like the English language. It's just like the internal mindset that gets pushed out when talking about technology like that.
That's true.
No, yeah, then I see that there are no more questions coming in right now. So thanks again, Patrick, for the great presentation today. And thanks everyone for joining in. So I really hope that once again we were able to show you an interesting new topic, and we really hope to also have you with us for our next events. As usual, you will find all the informations on Meetup, where we send out invitations. So if you just got the link to today's event from a colleague, for example, make sure to also subscribe on our Meetup page, or you can also find more information about OWASP itself on owasp.org or our specific local chapter here in Switzerland on the URL displayed here. Thanks again for being here. We have a lot of cool topics in our pipeline, and if I'm not mistaken and everything works out, our next topic will be about threat modeling, which is also a very interesting topic. So by that, thanks for joining in today, and see you next time. Bye.